Hi everyone. Let's look at solving first degree inequalities. Now there's a lot of similarity between them and equations, but there's a little bit of a glitch here, and which I'll bring up later here. Let's look at our first inequality here. X minus 4 is less than 2. Start out working it like a regular equation. We're going to add 4 to both sides. So we'll have x on the left-hand side and 6 on the right-hand side. X is less than 6. This is our solution set that makes the inequality true. Now here's our next inequality. Let's get all the x's on the left-hand side. So let's subtract 2x from both sides, and that should leave us with 6x plus 1 is greater than or equal to 13. Now subtract off the 1 from the left-hand side and also the right-hand side there, and we'll get 6x is greater than or equal to 12. Now multiply through by the multiplicative inverse of the coefficient of x, which is 1/6. Now as you can see here, the left-hand side just becomes a plain old x, and then we get x is greater than or equal to 2. Now, I would like to bring up the problem with working with our inequalities here. There's something to be aware of. Look at this. A negative x is less than 2. Let's multiply through by a negative 1 so that we'll just get a positive x on the left-hand side. And we'll come up with our solution set here. X is less than negative 2. Now, let's pick a number, let's say negative 3, that is less than negative 2, and substitute that into our original inequality. And what we're going to be left with is 3 is less than 2. That is a wrong statement. It's not true. Let's see how we can correct this situation. The secret is that we have to turn the inequality sign around when we multiply or divide through by a negative. So we get x is greater than negative 2. So let's pick something that's greater than negative 2. Let's say 3. Substitute that back into the original inequality, and we'll get negative 3 is less than 2. That's a true statement. So be sure to turn the inequality sign around when multiplying or dividing with a negative. Okay, let's take a look at a problem that hits this kind of a situation. So we start out here, and we're going to add 3 to both sides here, and that will give us a negative 4x is less than or equal to 4. Multiply through by the multiplicative inverse of the coefficient of x, which is negative 1/4, and then on the left-hand side that just becomes x, and we'll get x is greater than or equal to negative 1, because we had this, it's greater than or equal because you had to switch it around because you multiplied by negative. Okay, now let's do an application problem here. Here is Newton, and he wants to plant a garden, and he put in some magical seeds there, and he's waiting for them to grow, and he does this every year, makes this nice garden. And he's got a problem though. Every time he plants these seeds, he gets these plants that the rabbits come along and eat. So, oops, there comes one right now. It really ticks him off. And in fact, it looks like he's going to chase after that one right there. Now, let's look at Newton's garden here. It's a rectangular shaped garden, and it has a length and it has a width. And let's label the sides as L or W for length and width. And let's say we're dealing with feet here. Okay, now let's say we're interested in the perimeter, the distance around it. That would be represented as P. P equals 2L plus 2W. And let's further say that L is 2 feet longer than the width, and we want to get a perimeter that's less than or equal to 48. So we can come up with this inequality. 48 is less than or equal to 2L plus 2W. Now, we know that L equals W plus 2. So let's substitute that in for L, and then we can solve for the width. Now, what is the maximum width that we could have to have a perimeter that's less than or equal to 48? Let's see what that is. We work the problem out here. Here we got 48 greater than or equal to 4w plus 4. We'll take and we'll subtract 4 off from each side, then divide through by 4, and we'll give 11 is greater than or equal to w. So this is the maximum. 11 is the maximum that we can have for the width. So let's just pick 11 and stick it in for w, and we'll find out what the length is, and that's going to be 13. Now we know the length is 13 and the width is 11. Substitute back into the formula for the perimeter, and it works out to be 48. Now we could have picked something less than 11, and our perimeter would have been less than or equal to 48. Okay, thank you.